Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi. This video will be part 3 of my SolidWorks mini vacuum cleaner. In my previous video, I have already shown you how I have done detailing of this. This is a front casing, this one is a rear casing. And I've shown you how I've done the detailing of this rear and front casing, but actually I have not yet completed detailing of this front and rear casing, since I've not yet made the internal structure. We have internal structure, so this is a rib structure to support the batteries. See here also, you can hear at the front casing we have a structure there, and also we have a structure there to hold the DC motor. And here also on the front casing, on the rear casing here, we have a structure to hold the DC motor. Alright, I will not complete the detailing of this front and rear casing unless if I've done the part modeling of all the internal components, like for example the impeller, the DC motor. Actually the DC motor I've done the part modeling. I've not yet done the modeling of the standard batteries here, the rechargeable batteries, and also I have not yet done the part modeling of this PCB, because those three parts here, the DC motor, the batteries, and the PCB, is a standard parts. I will do the part modeling of the batteries and the PCB. I've done the DC motor, and after I've done all the modeling of this part, and also after I've done the modeling of the impeller and also the orange cap at the back here, then only I will do, not in this video but maybe in the next video, I will show you how I will position the DC motor. I put it into position, so it means that I will do detailing of the front and rear casing here by position all the internal components here. For example, I place in assembly mode, in SolidWorks in assembly mode, I will place the DC motor connected to the impeller and also the orange cap at the back, and also I position the batteries, and I already position the PCB at the right position. Then only I will create a supporting structures like the ribs here and also the ribs here, the supporting structure to hold this component. So that's how we do things in SolidWorks. It means that you cannot do complete detailing of your front and rear casing except after you have done the internal parts, all the parts inside your casing. For example, the impeller motor, I put it in position, and the batteries, the PCB, I put it in position in assembly mode, not in part modeling mode. Then later in that assembly mode, then I can do editing of the front and rear casing to do the structure, supporting structure to hold the parts. Actually, you can see in my previous video, I've done portable mist spray fan, make frotter, electric eraser, and so on. That's the way I do it. I position all the internal component first, then only in assembly mode, then I do the complete detail structure of the front and rear casing. Okay, so in this video I will show you how I will do the internal parts first, the part modeling of the impeller and also the orange cap. I will not show you how I've done the modeling of the DC motor and the batteries and the PCB, since those three things are standard parts. Alright, so in this video I will show you how I will do part modeling of this impeller and also the orange cap. So let's get started in SolidWorks. Alright, before I go to SolidWorks, let me explain to you. So this is the impeller connected to this DC motor, high RPM, 20 to 40,000. And the way it works is that when the motor rotates high RPM, so since this impeller is connected to this motor, so the impeller also will be rotated. The type of impeller is more, if you look at this photo, is a centrifugal radial impeller. So it means when the motor rotates, so this impeller rotates this direction, it means the inlet of the air is toward the center parts. Since we have the opening here, so the flow of the air is follow the curve of the blades. So when it's rotated high RPM, it will create a vacuum effect, right? It will create a vacuum effect as shown here. So since this is the cylindrical container to collect the dust with the filter inside, so it's connected to here, it will be fitted into here, then it will create a vacuum effect inside these containers, and that's why it will sucks the air inside. So that's how things work in many vacuum cleaner. Alright, let me show you again. Okay, to do the modeling of this impeller, so we have this shape. Okay, it's a this shape. The base is a this shape, and here we have the number of blade is 9. I already make a sketch dimension as shown here. So this front view, and bottom one is a side view. So the base this shape is diameter 45, and we have a number of blade is 9, and also at the center we have the opening at the hub at the center there, and the diameter, the opening is diameter 10. Alright, so I will create first the base this shape. Alright, so it means that in SolidWorks I will do a new part modeling. Okay, new part modeling, then unit measure is mm. So I will go on the right plane, so I will create this shape size by the diameter of 45, diameter of 45. Then I will do features extrude of 1 millimeter, and now at this plane I will create the blades. Alright, to create the blades I will base on this dimension. I have a diameter 4 at the center here, since we have an opening like this. So it means at here I will create not diameter 4, sorry, diameter 10 at the center here, diameter 10. Right, as shown in this sketch here with dimension as well, opening diameter 4, and I will create the curve for the blades. Right, so I will do what I will do here. I will go for center line. I create at this quadrant and stop at that quadrant, and I will create another center line. So to make the curve, I will give a guide line for, so this center line from this center to about this point. Okay, to about this point, and I will give a angle. I will go for 60 degree. I can play around with the value of this angle, but I go for 60 degree, and now I can do 3-point arch to create the curve for the blade. I will not do spline, I will straight away do 3-point arch. So the first one will be here, the second will be there, and I drag it something like this. As you can see from this photo, it can go to curve like this, but I think the curve that I've done, the angle is too much. If I go for, let's say, 45 degree, okay, 45 degree for the angle. Hold on. So at 45 degree means that I can, okay, I think this is about right. So here the curve, I can control the curve like this, how much the curvature I want it to be. If I go for like this, alright, so this would be the curve, and I give a dimension to make it fully defined. This one is 16, so I go for 17. Right, 17. So this will be the shape of the blades. Okay, the shape of the blade, and this one I can, okay, I can change the center circle here as construction geometry. Alright, here now, since this is a thin curve, since if you look at this photo, we have kind of a thickness for the blade. Alright, actually the blade is not, if I look at it, the blade, this one is not kind of like pointy, but this one we is have a uniform thickness. So I follow the same. So it means that I will give offset. I will go for offset about, if I go 0.25. So since it's a thin one, 0.25, I mean the thickness at both direction. So make sure that bi-directional is on, and if I click at the curve, so we have like this. I can even go for 0.15 because since it's a thin blade. Okay, let me go for 0.2. Right, for 0.2, and this will be the blade. And here about the cap ends, I will not check at the cap ends because I need to trim it. So I just remain it like this, and I click OK, and the center one will be a construction geometry. About this one I can drag it like this. Later I will trim it together on it. Okay, this one I need to change this one back to solid line. It's not construction geometry. Alright, also this curve here, so this one I will trace the outline, convert entities. So this one I can outline it. Okay, this one I can, if this one I cannot stretch it, so it means I can, another thing, extend is something new to you. It's not trim. Under the trim here I have extend. Since I have a border curve here, I can select this one to extend, so maybe it will stop until this border. For this one I can trim it. Alright, I need the outline for me to create the blades, so it means that I can trim this part. So I can trim this, I can trim this one, and I have the outline there, and also I can trim this one and that one, so I have the shape for me to do extrude. Also I have to trim this, right? So I have the shape for me to do boss extrude. Now I will do boss extrude. If you look at this photo, the total thickness from here to here is 10. So here I will do features, I will do extrude, I will go for 10. Okay, this one is 10. Actually this one is 1 already, so I have a thickness of 1, so I will go for 9. So you mean the total thickness from at the back there is 10. So this will be the blade. Alright, this will be the blade and one blade. So what I will do, and I will do circular pattern, then the direction will be the circular edges, and the features to pattern is this one. Alright, so this is 4, I go for 9. Since the number of blades is 9, then I click OK. So now I have the blades, right? So this is the blade, but actually the blade is we have if you look at this photo, we have a curve like this, so the way I do it, okay, if you look at the way I do it, okay, let me go to standard view. Alright, the way to do it is that I will go for the front view, make a sketch. So I will do a revolve cut. So I have to create a center line first from this origin up until here. Make sure they snap at here, right, a center point. Then I will create, since as you can see, okay, actually the sketch here, if you look at the sketch, is this direction, so I go to the other side, to the other direction, right? So since this is 5, it means that I will go for, I make a 3-point arch also, and goes like this, and one is here, and the curve is like this. Alright, about here, actually if you look at this photo, it's kind of like I make it tangent, so it means that I create just a center line straight up like this, make sure it's vertical, and I make sure that this one is tangent. It means it remain tangent, so I can drag it like this, and the distance from here to the here is 5 units. So 5 from the back, so it means the distance from the back here to this point is 5. So this is 5, right? This one is 5, and from the center point to here is, as you can see in this photo, we have diameter 4, right? So it means that from dimension from the center line to here, the diameter is 10, so it means the distance here is 5. So this one is 5. Alright, this is 5. So now what I will do, I will create, since I want to use revolve cut, so I mean I have to close the loop here. So this one I can trace it like this, and it goes like that. Okay, then I will do revolve cut. So here in the features we have revolve cut, and the axis of revolution is this, and if I click OK, as you can see, we have kind of like the outcome is like this. We have kind of like excessive here. Okay, in order for me to solve this problem, so under sketch here, so I will edit the sketch, so I make a little bit extended version here to make sure that the revolve cut will works properly. Alright, so here I will create a corner rectangle. I go like this, and here I set this, and this one is collinear, and I will give kind of like the dimension is 1. Alright, if I exit the sketch, I just exit the sketch and rebuild anyway. We have a alright, actually cut revolve is, I need to edit it instead of, because I'm using contours. Make sure that this contours, and this contours is selected. So I click OK. Now the cut revolve is clean. We don't have any errors here, right? Okay, let me save my file. I save the file as Impeller. Okay, I already named the file as Impeller. So here, okay, if you look at this photo, at the center there we have a center hub there, and actually the center hub, the height here is about 7 from this surface here, and also we have at the center we have inner holes. Actually the inner holes, the diameter is 1.5. Diameter 1.5 is the shaft from the DC motor, right? So it means here I create at this plane, I create the center hub at the center of, if you look, the hub diameter is 4, then then I will alright, I will extrude it. Alright, I will extrude features, extrude, and here I will go for 7 from here, and I will do both direction. If you look carefully here, actually we have both sides. We have a hub on the left side. It's not shown here. In my case, I will do both direction. One is there, another one direction 2 is at the back, but it's not too much. I think it's about, I can go for 3. So we kind of like have a little bit extra 2 millimeters here. Or if I go for 2 millimeter, maybe we have some extra of 1 millimeter there. So I will go like this, and I click OK. So I have the center hub on both sides, and here I can create a cut through holes of the diameter 1.5. so this will be the shaft diameter of the DC motor is 1.5 millimeter. So this one will be 1.5. Then I will do extruded cut through all, right, through all. So I have this one. Okay, I will save this one as Impeller. Alright, the next thing to do is about this orange cap at the back here. If you look at this photo, and alright, to do this part modeling of this orange cap, okay, I already make a sketch dimension of that orange cap. If you look the close-up version of this orange cap, so this is on the top side. If you look here, this is a bottom side. So you can have the shape. Like we have a grill. Later I'll show you how we create grill. But the first thing, I create the overall shape of this orange cap here. So it's kind of like we have a cutout like this. We have kind of like a dome shape, and at the side we have like this. Okay, to do the part modeling of this kind of shape of this orange cap, so the best way is, I found out, is to do by we create a profile, and we will do a revolve, boss revolve. Right, I already create a sketch of it, dimension of this. If you look here, so this is a rough dimension. Actually the outline is this, if you look, this pencil trace outline. So this will be the only outline that I need, and I already make a corrected dimension here, actually 24.5. so it means this is a axis of revolution. So I will create a half profile shape of that orange cap, and later I will create a straight line at this. Hold on, I will create a straight line from here to it to enclose the shape. Alright, just let me undo it. Right, first I create this outline. I already have the dimension, so it means half this is the axis of revolution. So 24.5 is the half of it. So I will draw this profile. So in SolidWorks, so I will go for the, hold on, so I will do the part modeling. I will go for part modeling, then I will do it in front plane. Okay, so I will create a center line first. Alright, center line from here to here. Okay, as you can see in the sketch dimension, the total width is 11. So I will put a dimension of 11 mm here. Right, 11 mm is the total width. Alright, the thickness of the cap is 11, and I will create a profile same as like this. We have a kind of like there, it goes down here, we have a chamfer like this, and so on, and here we have a kind of like a curve. small like a curve. So let me show you in SolidWorks. So I will create somewhere. I will start at this point like this, and it goes, we have kind of like a small chamfer. Hold on, let me zoom in, something like this. It goes like that, and it goes like this. It goes a bigger chamfer like this. Okay, let me check again. Like this, go like that, and it goes this direction. Then it goes, hold on. So I draw line again from here to this direction. It goes like this, and it stop there. And here we have, I do 3-point arch here and here like that. The curve is something like this. Let me put this one something like this, and here I will create a center line which is vertical, and I will create relation this one and this one to tangent, so it will remain tangent like that. Okay, this one I can simply drag a little bit in the side like this, right? So this kind of like a dome head. We have kind of like a dome head. If you look at this photo, we have kind of like a dome head like this. So this one will be part. If you look at, that's why I draw the profile. If you look the shape of the profile to be boss revolve like this, we have a chamfer like that, right? It depends how's your cap looks like. Mine is like this, so I will make a profile of this. So I will put dimension as mentioned. So 24.5 is from here to here, so it means that I will give a dimension. Before that, this point and this point must be hold on, this point and this point must be vertical, right? So it means it's maintained in that position. All right, the dimension is 24.5 since the diameter is 49, so half of it is 24.5. Right, if you look at the if you look at the, here is chamfer 1.5. We have a chamfer 1.5. So here I will create, hold on, I will give a dimension from this point to this. Okay, hold on, dimension from here to here is 1.5, and this one, and here to also 1.5. Right, as you can see, whatever thing I already put the dimension, it becomes fully defined. So the only thing, this what is will be this distance to the center line here. So this line to the center line as shown here is this is 22.5. Right, 22.5 from this line to this center line will be 22.5. Okay, 22.5. So what is this distance? It will be 6. As you can see, this is 6. Oh, hold on. So I put a dimension here is 6. Okay, this one is 6. And okay, another thing is about this one. This point to the center point, to the center line, is 23. As you can, this is 20. Alright, this is 20. So it means from this point to this line is 20. Okay, alright, this part is already fully defined. Okay, about here, and as you can see from here, this is 4. Okay, this is 4. This one is blue color, but I have not yet given the distance from here to the center line. The distance is, as you can see from here, is 15. Right, here to the center line is 15. Right, so let me adjust this thing first. This one can be adjusted. It goes like that, right? And I already gave this one is 15 from here. So about this curve, as you can see, 7.5 and 3. So it means from here to this line is 7.5, and from this point to this point the horizontal is 3. Okay, is 3. Okay, now I have a fully defined outline, the profile, so I need to make an enclosed shape for me to do boss revolve. So I will do a line here from this point to here, and it goes there. Alright, now I can go features, I go revolve boss base, and the axis of revolution, this line, so full circle. So I have this. Alright, this is solid things. If you look at this photo, this is hollow. If you look at this side, if you look at this photo, this side, so it is hollow, so the thickness is 1. So I will do shell. So I will do shell here, shell. So I go for thickness of 1 millimeter, and I will select this one, then I click OK. Now I have this thing, right? I have this thing. So this is a rough shape of the orange cap, but as you can see here, actually this is if I just to show you, if I go for section view, actually the actual thing of my orange cat, I need to make a closed shape too. I need to boss revolve because it is not a cutout here, so it's kind of like a solid shape. If you look at my photo, it's kind of like, if I show you, this one is more like a solid. We don't have a cutout like this as shown in this. We don't have a cutout like this. It means kind of like it's flat. If I look at my actual product, it's kind of like flat from here. I don't have a cutout here, so it means that I make another boss revolve. I off this one, so I will go for front plane, right? I go for front plane, and I will need to create the outline for me to close this cutout, right? To close this cutout. So I'm sketch plane, then I go for normal view. So it's hard for me to see, so I will go for display style to hidden line, so I can trace the outline there. So it means that this line and this line and also this line, I convert entities, so I have a trace outline there. So then I will create a line from here to here, and like that. So I have an enclosed shape. Okay, if I go for display style shaded mode, okay, I have this, and I can trim this. Okay, I can trim this outline. Okay, see, I have, okay, I still blue color, so I need to hold on first. I need to make it fully defined. I go for perpendicular view, so this one I have to make it fully defined. Alright, here I create a center line like this because I want to do boss revolve, right? So here I can make it this thing, and one way is I can put dimension from here to the center line. I just remain it like that because it's already 21.5, so it's a fully defined. Okay, now I can do features, revolve, and already selected this one, and make sure it merge the result, so it kind of like close the shape like this. Alright, so this, let me save first. This my I will name it as a rare cat. Okay, rare cat. So this will be the rare cat. Alright, the next thing to do, if you look at this orange cap, so this bottom side, if you look, we have a features like a grill here. The number of grill is 16. So in order for me to create this thing, I need to make a cutout. A cutout is kind of like a pie shape, right? A pie shape of this one. Actually, the pie shape is not from the center point and make a center line. So this is a wrong way to do it. So I show you in SolidWorks. I will use by offsetting. Alright, but first I need to make this, as I mentioned to you, a triangular shape, right? Actually, this triangular shape is here, is not pointing to the center point here. Alright, for me to do that, okay, before that, one thing I need to explain is about here we have a curve here. If you look at my SolidWorks, this is the other side. It's not a sharp edges like this, so I need to make a curve shape. So I will put some fillet first. So here I will do some fillet. So the fillet will be around, let me go for 2 millimeter. So I will select these edges. So I think 2 is good enough, compare with this one. Alright, so 2 millimeter. so I will create fillet of 2 at this side. Since I do a shell of thickness of 1 millimeter, so it means at this side I need to fillet it 1 millimeter, since the thickness of the shell is 1 millimeter. So I will select at this side, so I will create a fillet at that side. If you look at the section view, so it means that we have a uniform thickness. Right, be careful about your exterior fillet radius and also your inner fillet radius. So I have a uniform thickness of the fillet. Right, okay, let me save my file again. In order for me to create the grill shape, okay, as shown in this photo, the number of the grill is 16, so I need to create a pie shape, as I mentioned before. But this pie shape is not, this point is not pointing to the center of this curve, right? It's not pointing at the center. So here, so the way I do it is like this. Okay, since I have a flat surface here, so I will create sketch at that plane. So I will create a center line from this point up until at these edges, not in one here this circle. So make sure I snap at that quadrant point there. Okay, next I will create another center line here, another center line. Hold on, another center line from this point to this point, somewhere around here. Make sure you snap at this circular edge. About the angle is not too much, about something about this much for the angle. Later I will give a dimension. I just try and error first to get the real result like this, right? The result like that. Alright, I will not okay, I already mentioned that I need to create kind of a pie shape, so I will not trim like the shape of the pie. So if I do that, I make a shape of a pie by this one, so it means that when I do circular pattern, it's kind of like this one, the thickness is minimal because it's pointy to the center, and this one, the arm is much thicker. So that's not the way. Okay, let me show you what I will do. I will create offsetted here, so this line. Alright, this one I actually change back to solid line, not construction geometry. Okay, as a solid line. I try around this angle, but later I will give exact dimension of the angle. Okay, now I will do offset. So the offset I will go for, if you look at the photo, so there is not too thin. I want to create the arm, okay, the outline of the arm. So I will do offset of, if I go for 1 and I go for bi-directional, if I select this line, it's about that thickness. So I think 1 is good enough, and also I select this one to make that thickness. Alright, okay, like that. So I have this shape. Okay, I can adjust this now. This one, remember the one that I make this thing, I adjust is about not too much about this angle like this. Alright, so now I can give a dimension. The angle from here to here is, if I can go for 21 degree. Right, for 21 degree. So I have the outline here. Okay, what I need to do, since I need to do boss extruded of a pie shape, right, so I need to trace the outline here. It means that if I go back to perpendicular view again, so this line I need to trace it, convert entities, and also I need this circle. Alright, I don't have an inner circle. If you look at this photo here, actually we have a circle, this circle. Alright, I need to create that circle. So it means at here also I need to create another circle of about this size. So I will go some dimension of I go for 16. Alright, I go for 16. Okay, hold on. So I have a 16 circle there. Alright, now I can use boss extrude by using contour. Okay, by using contour, then I will do features. I will extruded cut. Okay, that direction is that direction. I'm using contours. Make sure select the contours. I will select, hold on, I will select these contours and also these contours, and I go for around, not too much. It's kind of like, okay, if I go for 3, okay, I'm using blind, then I click OK. So I have this carrot. As you can see, I have a pie shape carrot. Okay, actually this surface and this surface is not pointing to this, right? It's not actually pointing, it's kind of pointing to here. So now I will use a circular pattern. I have a circular pattern, and the direction is this edge, and the features to pattern is will be this curve. Okay, I will go for 16 value, right? 16, since the number of arm as shown is 16, right? Then I click OK. Then I have this thing, right? It's kind of like a sport rim. Okay, so this actually my orange cap. Okay, if I look, it's kind of like too thick. It's too thick here, so I can adjust it with the cut extrude here. Instead of either I can if I change the either the angle here. If I go for the angle is, for example, I make it 23 degree, just to show you. If I make this to 23 degree, if I exit, I have a bigger pie shape, right? So it's kind of like, I think this is good enough, right? Compare with my original one. So I have a grill shape of my orange cap, right? Okay, I think that's all for this video. I have successfully done the part modeling of the first part. Just now I have shown you how I've done the part modeling of the impeller, and this one is for the orange cap. Alright, okay, before I end up this video, please do appreciate by click like, subscribe, and also promote my video. I will see you in the next video. Assalamualaikum warahmatullah.